when we're in intercept form is when it's in its factored form. We typically see these like sets of, I don't know, maybe a greatest common factor and sets of parentheses. We see this after we factored. Intercept form is kind of like factored form. Here's how we found the vertex. To find the vertex, we first have to identify where these x-intercepts are. One of the x-intercepts was P. The other one was Q. And we had to figure out the vertex is directly in between them. To find the middle between two numbers is kind of like finding the midpoint. If we tried to find the middle, it's like finding the midpoint. To find the midpoint, the x-coordinate, so if I'm trying to find my vertex, the midpoint would be taking those two intercepts and dividing them by 2. And then we'll plug that value in to see what the y-coordinate is. I guess yesterday I used a y to represent the y-coordinate. Let's say I'm given the equation y equals 2 times the quantity x minus 3 times the quantity x plus 1. Or let's say I was given another equation, but I get this into factored form using multiply add. I look to see what would my x-intercepts be, and then I'm going to find what's in the middle, what's right in between them, because that's going to be the x-coordinate of my vertex. The other x-intercept is -1. My vertex is going to be whatever 3 plus -1 is divided by 2. It's going to be the middle. And to find the middle, it's like finding the midpoint. So then I'm going to plug in 1 into the equation. We're going to plug 1 into the equation. So I'm going to do a little side work over here. Y is going to equal 2 times 1 minus 3 times 1 plus 3. Notice how I put the 1 into the original equation where the x's are. I'm going to do parentheses first. So I'm looking at 2 times -2 times a positive 2. So my y-coordinate of -8. In your notes, we talked about how the x-intercepts were going to be P and Q, and then we would graph them and look for the middle piece. But when we don't have a graph that we're dealing with, this is the algebraic formula, where to find the midpoint, you add the 2, divide them in half, because the vertex has to be in between them, exactly in between them. We're going to go through each equation set and see if we can identify where the axis of symmetry is. Maybe we need to recall the definition of the axis of symmetry. Axis of symmetry is the line of reflection, and there was a little piece that was missed yesterday. Axis of symmetry has to run through the vertex. Axis of symmetry has to run through the vertex. It's got to run through the vertex. So if I know what my x-coordinate is, because it's going to be a vertical line, if I know what my x-coordinate is, that's going to be my axis of symmetry. So here's what I'm looking for every single time. I'm looking for x equal to a number. I put a little bracket on there. That's not part of the answer, just so you know. This bracket's not part of the answer. I'm just separating the two thoughts. I'm looking every time for x equal to a number. And that specific number is going to be the x-coordinate of my vertex. Yesterday we found the x-coordinate by taking -b over 2a. So the axis of symmetry is just going to equal whatever that calculation was. Let's say we're given this equation. Let's see if we can just find the axis of symmetry using this formula. Yesterday we talked about how keeping it in line with the quadratic formula, maybe map out what your A is, what your B is, since you have to use them. And then do the formula. X is supposed to equal the opposite of B over 2A. supposed to be x equals 2 over 2, or it's a line, x equals 1. In vertex form, typically the x-coordinate, h had to change its sign, k kept its sign. We're going to use that for our axis of symmetry. So x is equal to h. That would be our line. So now let's try, what if it was an intercept form? In intercept form, finding the axis of symmetry. To find your x-intercepts, it's always going to be the opposite of P and Q. In order to find my axis of symmetry, it's directly between, exactly between your x-intercepts. So if I could find the exact midpoint between P and Q, that's where my axis of symmetry is going to run through also. So we're just going to use that same kind of formula. I'm going to have the line x equals whatever P plus Q is divided by 2. Let's talk about finding x-intercepts. That's the next piece. When we find x-intercepts, we're talking about where we cross the y-axis. My bad. Where we cross the x-axis. And there was a specific piece, whenever we did this definition, a specific piece I wanted you to copy down, and it was the algebraic interpretation of an x-intercept. We have some type of number, comma 0. The y-coordinate is supposed to be 0. So I'm going to give you an equation, and we've got to figure out what our x-intercepts are. If I'm in standard form, first off, in any equation, if I need to find an x-intercept or a 0, I need to have a coordinate specifically equal to 0. This y-coordinate needs to be equal to 0. When you're trying to find the x-intercepts, the y-coordinate has to be equal to 0. Wait a second. The y-coordinate's equal to 0. Check out this type of problem. This is why we learned so many strategies on how to solve. We could either try to factor it, we could try to use completing the square, we could try to use quadratic formula, but when we find the x-intercepts, we're going to have to use one of those ideas. So let's pick one. So we can start by dividing both sides by 2. Just to deal with smaller numbers. Let's factor. You've got to see what multiplies to 1, adds to 2. This will break up into x plus 1 times x plus 1. So we could, if I have now, when you break it up into factors, you get a product equal to 0. That means one of these have to represent a value of 0. If you look at this set of parentheses, what would x have to be? If you look at this set of parentheses. So that means we only have one x-intercept, and it's negative 1. So the x-intercept is negative 1, comma 0. Same rules apply. If I'm trying to find an x-intercept, I'm going to plug a 0 into the y-coordinate. Let's say we start off with this equation, and part of this connections test, you got to find the x-intercept. So, if I'm finding the x-intercept, I need to realize that the y-coordinate has to be 0. So I'm going to put a 0 in for the y-coordinate and solve. So in this case, I actually have to add 16 to both sides first. So in this case, I'm actually probably going to use the square root method where I start getting this squared item by itself. Divide both sides by 2. Take the square root on both sides. let's talk about the square root of 8. I think there's a pair of 2's. So this turns into 2 root 2. My x coordinates are a little gross in this one, which we're gonna practice. We're gonna see what does it mean whenever you have a gross x-intercepts. We're actually going to have to plug this into our calculator. Maybe let's take some time and plug it in our calculator. Using our calculators to calculate, we got one of the answers to be about 3.8 and the other one to be, what, negative 1.8? Yeah. So we would not write our answers like x equals this, x equals this. It's got to be a point. So as a technical point, I would want to see the 1 plus or minus 2 root 2 comma 0. You have to do the algebra part, but then you still need to know their decimals because we're going to have to graph them. And if I don't know exactly what these are about, I wouldn't realize that one of these points is going to have to be really, really close to 4. And the other point is going to be, well, negative 1.8 is kind of closer to negative 2. I would need to know where these points are. So, intercept form. Finding the x-intercepts whenever it's in intercept form. Anytime you find an x-intercept, we're still looking for some type of x, comma 0. That's what I'm algebraically trying to find. So then this means that whenever I'm given a problem, I still have the y-coordinate equaling 0. No matter what type of equation I'm given, or what kind, what form I'm given, I'm going to have the y-coordinate be 0. Here's an example. Let's say we have the problem 2 times the quantity x minus 5 times the quantity x plus 1. I'm going to start out the same way I've done, where this y-coordinate is going to be 0. Y-coordinate is 0, and I've got to figure out how to solve it from here. So we can divide both sides by 2. When that happens, well, 2, or this whole side divided by 2 just gets rid of this 2. 0 divided by 2 is 0. I'm still left with this x minus 5 times x plus 1. I've got a product equaling 0. When you have a product being 0, you've got to figure out if I want this to represent the zeroed value, what would x have to be? So, if this was the 0, x would have to be 5. If this needed to represent the 0, x would have to be negative 1. But I don't write my answer like this. My answer needs to be a point. I've got one of my x-intercepts is 5, 0. The other x-intercept is negative 1, 0. So this is an example where I get 2 of them. And they're nice. Let's talk about finding the y-intercept. Finding the y-intercept in any form. So when we find the y-intercept, I'm looking for something algebraically that's like a 0 for the x-coordinate, when there will be a number for the y-coordinate. So when the connections test is looking for you to identify the y-intercept, you're going to plug a 0 in anytime you see an x. So it kind of reverses the stuff. We used to set a 0 in for y, but now we need 0 as our x-coordinate. So using the example from before, we're going to now figure out, well, if I plug in a 0 for x, plugging in a 0 everywhere I see x, but it's going to get rid of all these terms. The only thing I'm going to be left with is the constant, 2. So y is 2, but I don't write my answer like that. It's a point. And the point is 0, 2. When we plugged in 0, we got 2. Using the previous example, finding the y-intercept of this type of problem, I still plug in a 0 for the x-coordinate. I do parentheses. It goes parentheses, exponents, multiplication, subtraction. But my answer is a point. It's 0, negative 14. Let's say we have it in the intercept form. So using our last intercept, or our last equation example, plug a 0 in for the x-coordinate. but you write your answer as a point. It's a y-intercept. Whoop, whoop, whoop. There we go. Let's talk about this for a moment. End behavior is the last topic, and it all depends on what that leading coefficient is. If A is positive, as x goes left, or as x approaches negative infinity, the outputs, or y's, are approaching positive infinity, up and up. We also have to look at the right side. As x goes to the right, or positive infinity, y is also still going up, positive infinity. If A is negative, I'm going to have to still talk about as x goes left, or as x approaches negative infinity. If the leading coefficient's negative, you're going down and down. So you have to say y is also, y is going down, y is going negative infinity. As you move right, so as x approaches positive infinity, y is also approaching, no, y is approaching negative infinity. Now, no homework. All I needed you to do was just get through the material. Come Monday, Tuesday, we're strictly practicing.